In MCQ 4, we are cycling back to atomic structure under ionization energy, which is the amount of energy that an atom or an ion have to incur in order for it to lose a single electron. Now, the few members here we're investigating is a cesium cation of a 1+ charge, an iodine anion of a 1- charge, and a xenon atom. So writing out their electronic configuration, we have cesium plus initially started out with a total of 55 electrons. After going through the act of becoming cesium plus, right now I will say that the electrons count within would have been at 54. So writing that for I-, which started off with a total of 53 electrons. After gaining a single electron, we would now have a total of 54 electrons. And for the case of xenon, that started out with 54 electrons. And this itself is its original case because it have yet to lose or gain any electrons as an atomic xenon. Now you can see that for cesium plus, iodine minus, as well as xenon, they all have the same number of electrons. We'll say that all these three items are considered to be isoelectronic. And isoelectronic would just mean that they actually have the same number of electrons. So what then actually affect the next ionization energy that they are about to go through? I would then say that it's with respect to the nuclear charge. Otherwise, which is proportional to the number of protons that they actually possess in their nucleus itself. Being that if you have a much higher nuclear charge, this will result in a much higher ionization energy. So you can see that out of these three, cesium is the member that contains the most number of protons at 55, followed by xenon of 54 proton, and finally iodine of 53 protons. So from a decreasing enthalpy change, the highest would have first go towards enthalpy 1, which is that of the ionization energy of cesium cation of 1+, followed by that of enthalpy 3, which is the ionization energy of the xenon atom, and finally by enthalpy 2, which is the ionization energy of my iodide anion. So the correct answer for this question here is B.